This is the second lecture on the muscular system. We'll be talking about the muscles of the abdomen, the back, and the lower limbs on this lecture. Remember, muscles only pull, they do not push. First of all, let's talk about the abdominal muscles. There's 4 different abdominal muscles. And the first one, or the most starting from superficial to deep, the most superficial abdominal muscle is the external oblique. See, the external oblique is illustrated here. Its fibers run from lateral to medial in a downward direction. Compare that to the internal oblique, which is the next layer. These fibers run at different angles, 90-degree angles, different between the external oblique and the internal obliques. And then the deepest layer is the transverse abdominis, which runs transverse left to right. That's on the side. And in the middle, there's this rectus abdominis muscle. That's what gives you the six-pack. And that completes the 4 abdominal muscles. This slide just illustrates the depth of the muscles from going from superficial to deep. The more superficial muscles, first of all you have the skin, and then have the fat. And then the first muscle you encounter superficially would be the external oblique, then the internal oblique, and then finally the transverse oblique. Probably the transverse abdominis muscle is the deepest of the abdominal muscles. Here's another picture showing the abdominal muscles. There's our internal obliques here. These are external obliques on this side. The rectus abdominis here. You can't see the transverse abdominis on this picture. The erector spinae are muscles that run up and down the back next to the ribs and to the vertebral column. They're deep muscles. They're deep to the trapezius. They're deep compared to the latissimus dorsi. And they run longitudinally up and down the spine. There's 3 actually muscles. There's the spinalis, the longissimus, and the iliocostalis. But you use the collective term the erector spinae because they hold the spine erect. They help extend the spine and hold you in an erect posture while standing. Now we're going to move down into the hip. The iliopsoas muscle. The iliopsoas muscle is actually 2 muscles that are combined. There's the psoas major muscle, and there's the iliacus. Iliacus, it comes from the iliac crest, and so the iliacus muscle comes from the iliac crest. So the name kind of gives you a clue as where it's coming from. But this muscle, as you see, runs in front of the hip joint. Since it runs anterior to the hip joint, when that muscle contracts, it's going to cause flexion of the hip. It's going to cause the hip to, the femur to move in front of the body, and therefore flexing the hip. Actually, this is the prime mover for hip flexor. This is the strongest hip flexor. The gluteus maximus is on the other side of the hip. This is posterior to the hip joint, so this is going to extend the hip when that muscle contracts. It extends the hip. The gluteus medius is underneath the gluteus maximus. Gluteus maximus here, and have the gluteus medius here. It's an abductor of the hip. It abducts the hip. And if I have a slide next. Here it attaches to the iliac crest, and then it attaches. Also, it inserts over onto the femur. So when it contracts, it can. If you're standing on the opposite leg, you can abduct the leg. But also, it helps in normal walking just to prevent the tilt of the pelvis. If there's a weakness, like in this case, if this is weak, this muscle is weak. When you stand up on the weakened side, that muscle normally would contract and keep the pelvis straight, but if it's weak, the pelvis dips down on the opposite side. That's called a Trendelenburg gait, or Trendelenburg sign. That's due to weakness of the gluteus medius muscle. The pectineus muscle, you see here, it attaches from the pubic symphysis area, the pubic bone, and attaches over to the femur. This runs in front of the hip joint, so it's going to flex the hip since it's anterior to the hip joint. It's also going to adduct the hip because the angle that it's situated, when it contracts, it's going to bring the femur in towards the midline, so it's going to adduct the hip. And it's inserted on the femur such that when it contracts, it rotates the hip immediately. The next we're going to look at a group of muscles. These are the adductor muscles, hip adductor muscles. There's three that you have to know: the adductor longus, the adductor magnus, and the gracilis. The gracilis is the most medial of the muscles. Adductor magnus is larger. Adductor longus is next. And here's the pectineus again. All three of these muscles have similar function. They all flex the hip because they're anterior to the hip, but they're all abductors of the hip. They all bring the femur in towards the midline, and they all immediately rotate the hip. So they all have very similar function. The sartorius. The sartorius is a two-joint muscle. It's the cross-legged muscle, and the reason it's called that is because the actions of this muscle, it goes in front of the hip, so it's going to flex the hip. It's going to go behind the knee, so it's going to flex the knee, and it basically it creates the movements of when you cross your leg. If you cross one leg over the other, you think when you cross the leg over the other, you flex the hip, you flex the knee, you abduct the hip, and you laterally rotate the hip. All those are movements that the sartorius muscle does. That's why it's called the cross-legged muscle. And remember, it's a two-joint muscle, so that it has effect on the hip and the knee. Here's another picture of the sartorius. You can recognize it easily on the lab because it runs diagonally across the anterior femur region. All the other muscles run up and down, where this one runs diagonally. The tensor fasciolata is a hip abductor. It's located on the lateral side of the pelvis. It's really very near the gluteus medius, but it abducts the hip, and it helps steady the leg and the trunk while standing on that leg. The quadriceps. This is the strongest muscle in the body, and it's made of 4 different muscles. Quadriceps. When you hear the word quadriceps or biceps or triceps, the prefix has to do with how many origins the muscle has. Like a biceps has 2 muscle bellies, triceps has 3 muscle bellies, quadriceps has 4 muscle bellies. They have a common insertion, but they have different origins. But the quadriceps all flex the hip and extend the knee. So they go in front of the hip joint, so that when they contract, the hip is flexed, and that they attach in front of they attach to the anterior tibia. So when that muscle contracts, the knee is going to extend. It's not going to bend, it's going to extend and straighten out the knee. Again, this is another two-joint muscle, so it affects the knee and the hip. The 4 muscles are the lateral vastus medialis on the medial side, the vastus lateralis on the lateral side. You have the rectus femoris in the middle, and underneath the rectus femoris is the vastus intermedius. You can't see that vastus intermedius unless the rectus femoris is moved out of the way. Now on the back of the leg, or the back of the thigh, there's the hamstrings. There's 4 hamstring muscles. The semitendinosus, semimembranosus, the biceps femoris long head, and the biceps femoris short head. I want to illustrate the hamstrings. All 4 of these hamstrings cross behind the knee, so they all would have effect on flexing the knee. But the biceps femoris short head See if I have a picture of that. Here's the biceps femoral short head. It just crosses the knee joint. It does not cross the hip joint, so it does not affect the hip movement. Whereas the other 3 hamstring muscles also cause hip extension because they're located behind the hip joint, so when they contract, the hip is extended. Again, just remember the biceps femoral short head does not cause any hip motion. It only causes knee flexion. The tibialis anterior is the prime mover for dorsiflexion of the foot. Tibialis anterior is located next to the tibia. If you find the tibia, then the muscle right next to the tibia is the tibialis anterior. It's fairly easy to find. It also is a dorsiflexor, of course, but it also inverts the foot because the way that the tendon attaches, it attaches to the medial aspect of the ankle. So when it contracts, it's going to cause the medial aspect of that foot to come upward, therefore cause an inversion of the foot. The flexor hallucis longus flexes the big toe. And this is seen in the posterior portion of the leg. It inverts the foot, it flexes the great toe, and it helps to plantar flex the foot. The extensor hallucis longus extends the big toe. Extends the big toe. The extensor hallucis longus is similar to the location to the tibialis anterior, but it's located further down, closer towards the distal end of the tibia, as you see here. And also the tendon for the extensor hallucis longus just goes to the big toe. See, it follows it all the way down to the big toe. And it extends the big toe when it contracts. Looking at the posterior calf, posterior tibial region, the most prominent muscle is the gastrocnemius. That's the large the large muscle belly that has two halves. It is a knee flexor and it plantar flexes the foot. And this is a 2-joint muscle, so you have to know what it does to the knee and to the ankle. It goes behind the knee joint, so therefore it's going to flex the knee. It also attaches down on the calcaneus through the calcaneal tendon. That's also the Achilles tendon. When this muscle contracts, it's going to cause plantar flexion of the foot. The toes will go pointed downward and the heel rises up. So when you stand on your tiptoes, the gastrocnemius is what was responsible for that. It's a 2-joint muscle. Compare that to the soleus, is only a 1-joint muscle, and it just causes plantar flexion of the foot. The soleus is located underneath the gastrocnemius. The soleus does not cross the knee, so it has no effect on knee movement. It does cross the ankle, and it attaches to the calcaneal tendon just like the gastrocnemius, and it helps to contribute to a plantar flexion. So you could say the soleus is a synergistic muscle to the gastrocnemius when it comes to plantar flexion. The fibularis longus, or the peroneus longus, is an everter of the foot. If you find the fibular head and then go just inferior to the fibular head, you'll be right on the fibularis longus, or the peroneus longus muscle. And when that muscle contracts, it everts the foot. You see the tendon goes down and it attaches on the lateral aspect of the foot. So when that contracts, it's going to cause the lateral aspect of the foot to rise, and therefore everting the foot.